Welcome to Chapter 23, the last chapter of your physics career. How exciting! We are going to start with Chapter 23. We're going to talk about circuits. We are combining everything together, voltage, current, resistance, when we talk about circuits and how electricity can travel. So there's a lot of information that we can talk about when we're talking about circuits. Now there are two types of circuits. There are series circuits, where the more simpler of the type, and then there are parallel circuits. We are going to spend time on both today, and we start with series circuits. A series circuit is one continuous loop. So all current travels through the entire device. So right up here, you can see we got a nice picture of a series circuit. You have the battery and everything's connected on one loop. At any point during that time, if I cut that wire, the entire loop, the entire circuit goes dead. These are like the idea of the old school Christmas lights, where if one bulb went out, the whole strand would go out. And that is a series circuit. So we are going to study voltage, current, and resistance in a series circuit and see how it varies as it goes throughout the entire circuit. So current and resistance, voltage from a source is equal to the voltage drops across the resistors. So we are going to talk about this, mathematically apply it. When we are trying to figure out the voltage in a series circuit, what we can do is we can add up our voltage drops across each resistor, and that will figure out the total voltage in our circuit. Remember, using Ohm's law, which is resistance is equal to voltage divided by current, or voltage is equal to current times resistance, VER, we can kind of figure it out. So what you could see here is we just have a simple circuit diagram with a battery and 3 resistors. Each resistor is going to have a different resistance, which means that's going to have a different voltage drop across the circuit. So equivalent resistance. What we have here is, if I want to figure out for a series circuit, if I want to figure out the total resistance on the circuit, all I'm going to do is add up all the resistances, and that will be my total. So below here in the highlighted diagram, I have 50, I have 30, and I have, we'll make this last one 20. So the total resistance in that circuit would be 100. 50 plus 30 is 80. 80 plus 20 is 100. So in a series circuit, all you have to do is add up the total resistance. If you want to find the current in a series circuit, you're going to figure out resistance by adding the total together, and then you're going to use Ohm's law because you're going to know the voltage of your power source. A couple additional things here as we talk about series circuits, and we'll do a problem. Voltage drops in a series circuit. As the current moves through a circuit, the net change must equal 0. So as the current moves through a circuit, the net change, so there is going to be no change in voltage as it goes through. And the voltage divider, a series circuit, is used to produce a voltage source of a desired magnitude from a higher voltage battery. If you need 5 volts from a 12-volt battery, you just are going to tone it down with resistors. Don't worry necessarily about that. We'll kind of explain this mathematically. What I want you to do is really a couple things. Be able to draw a diagram and be able to calculate voltage, current, and resistance in a series circuit and a parallel circuit. So if we look here, we have 2 resistors of 47 ohms and 82 ohms are connected in a series circuit across a 45-volt battery. What is the current in the circuit? Well, we can solve for current using voltage is equal to I times R. We have our voltage. Our voltage is 45 volts. We need to figure out our resistance. Remember, to figure out the overall resistance in a series circuit, you're going to add together all the resistors. Well, we have 47 ohms plus 82 ohms, so our total resistance is 129 ohms in our series circuit. We can go ahead and solve for our current. Voltage is 45 is equal to I times resistance, and our resistance is 129. We do a little bit of algebra, and our current with 2 sig figs ends up being 0.35 amps. Next part question number 2 is asking what is the voltage drop across each resistor? Well, again, we want to solve for voltage. Voltage is equal to current times resistance. In the first resistor, the current is 0.35 since that's the current throughout, and the resistor is 47 ohms. 0.35 times 47 ends up equaling 16 volts for our first resistor. If we figure out our second resistor, voltage is equal to, again, current times resistance. As we just solved for, our entire current throughout is 35 or 0.35 amps times the resistance in the second resistor, 82, and we figure that out, and that is 29 volts. Notice anything? What would happen if I added these two voltage drops together? 16 plus 29, it equals the total voltage of the battery, 45. So just kind of one thing to keep in mind there. The voltage drop among each resistor is going to add up to the total voltage. So we solve for current, resistance, and voltage in a series circuit. How about in a parallel circuit? Well, a parallel circuit, if we were to draw one, is going to look like, very basically, this, where I have multiple pathways for charge to flow. So I have multiple pathways for charge to flow. I could add light bulbs on each one, and what would happen here is if I cut right here, 2 of my light bulbs would not work, but I would still have one path and my circuit would still somewhat function. And this is what kind of newer Christmas lights work upon, this idea of parallel circuits. The difference, though, is with parallel circuits, our equations change. With series circuits, we are able to add our voltage together. We are able to add our resistance together. With parallel circuits, we are going to have to focus on our currents. We're going to have to add the current from each resistor drop to figure out the total current in the entire circuit. Also, with resistance, for series circuits, we are able to add resistance. 1 plus 2 plus 3, boom, add them together. With parallel circuits, we have to take 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, depending on how many resistors there are. So 1 over R total, so if you wanted to add a little total here, is equal to 1 over R1 plus 1 over R2. Now, this varies much differently than a series circuit, and we kind of figure this out much differently than a series circuit. So first things first, let's look at this problem. 3 resistors, 60 ohms, 30 ohms, and 20 ohms are connected in a parallel circuit across a 90-volt battery. First things first, draw the circuit. Well, here's my battery, which is 90 volts. That's going to go to one resistor. I'll have a second resistor. I'll connect that using a third resistor. And my resistors have 60 ohms, 30 ohms, and 20 ohms. Those are my resistors. So that's what my phase diagram would look like. I have not my phase diagram, my circuit diagram. I have voltage and I have my circuit, I have my voltage with my battery and my resistors. 2, find the current going through each branch of the circuit. Well, we have 3 branches here. We really have 1, 2, and 3. So what we're going to go ahead and do is find the current of each one. So voltage is equal to I times R. In the first example, that is equal to our 90-volt battery is equal to its current times 60. Do some algebra. 90 divided by 60. Our current in our first one is 1.5 amps. Go to our second one. Voltage is equal to current times resistance. Again, 90 volts is equal to our current, times our resistance in our second one, which is 30. 90 divided by 30 gives us 3.0 amps. Last up, in our third circuit, we're going to do the same thing again. Voltage is 90. That's equal to I times resistance. Our resistance is 20. 90 divided by 20 gives us 4.5 amps in our third circuit. Now, if we are to add up all three of these currents together, which if we did, we'd get 9.0. That would be the current of the total circuit. We figured out the current in each individual one, so now if you add those all up, that'll be the total. Next up, it says find the equivalent resistance. Remember, when you're solving for the resistance in a parallel circuit, it's 1 over R total is equal to R over R1 plus 1 over R2. And in our case, we have 3 resistors, so 1 over R3. If we go ahead and plug in those numbers, what we're left with is 1 over R total is equal to 1 over 60 plus 1 over 20 plus 1 over 30. If you were to do that mathematically in a calculator, you could go ahead and do that. Or what you could do is you could make all of these common. So 1 over 60 plus 1/20th would be 1/20th would be 3 over 60 plus 1/30th would be 2 over 60, and you would get 6/60ths. Well, 1 over R total equals 6/60ths. You simplify that, and R total, and again, you could do this by hand doing fractions, or you could do it in your calculator. R total is going to be 10 ohms. So the total equivalent resistance on that entire parallel circuit is 10 ohms. Last question says, find the current throughout the battery. Well, we've already done that. We already solved for each individual current in part 2, and we added them all together to get 9 amps. But what we could do is we could go ahead and prove this. Again, using Ohm's law, voltage is equal to current times resistance. That's equal to, our voltage in our battery is 90. We just are going to prove our current, and our resistance was 10. Well, what is 90 divided by 10? That is 9, and our current ends up being 9.0 amps. So that kind of concludes what we're talking about with series and parallel circuits. We will move on to what happens when we use circuits and what happens when we combine series and parallel circuits in 23.2. But that concludes today's assignment or notes, and you'll have an assignment tomorrow.